Okay, so fraction part of the smaller number bigger than fraction part of the bigger number in a subtraction, I got to do something. I cannot just subtract these. So option one is to rename the bigger number with a bigger fraction. So it starts as 2 wholes and 1/3, right? Well, I can take one of these wholes and make it thirds. So now I have 1 whole and 4/3. Okay, so I can rename this first number. Instead of 2 and 1/3, I can rewrite it as 1 and 4/3. They are the same number. The same amount of stuff is shaded. You can do it in circles over here. 1, 2, and 1/3 in red. Or 1 and 1, 2, 3, 4/3 in red. Okay, this is called renaming. Then, once you rename, now the fraction part of the larger number is bigger than the fraction part of the smaller number. And now I can subtract the whole number parts and subtract the fraction parts. So 1 minus 1 is 0, and 4/3 minus 2/3 is 2/3, and 2/3 is the answer. Is it about 0? Yeah. Okay. Over here, so visually, I start with 1 whole, 2 wholes, and 1/3, and I take away 1 whole and 1/3 and 2/3, right? So if I take away all these, minus 1 and 2/3, I'm left with 2/3 as my answer, right? So graphically, that's how it works. Now, the other option here, instead of renaming the larger number, is to convert both of the numbers to improper fractions. Okay, so if you get in this problem again, where the fraction on the smaller number is bigger than the fraction on the larger number, then you can also go to improper fractions. Now, for this problem, it's not too bad. 2 and 1/3 is 7/3, 2 times 3 plus 1. And 1 and 2/3 is 5/3, 1 times 3 plus 2, right? We talked about going back and forth from improper fraction to mixed number. You need to be able to do that without too much trouble. You should be able to do this, okay? So now 7/3 minus 5/3 is 2/3. Very simple, okay? So for this problem, improper fractions is a good strategy because the whole number parts are small, the fraction parts are small. If you have problems that look like this, these can be terrible with improper fractions, okay? The strategy for improper fractions, when you have large whole numbers or large denominators, you end up with really big numbers that you have to use a calculator for, okay? So it's not the best strategy. Plus, then at the end, you end up with an improper fraction that you have to figure out what the mixed number is. You can do this every time. And it's safer, right? It's easier process than renaming, but you're going to end up with a lot of crappy arithmetic if the numbers are large, okay? But you always have both options. You can rename the bigger number, take one away and make the fraction part bigger, or you can rename both of them, or you can do both of them as improper fractions, okay? So the got it's here. We'll do one of these, letter G on page 301. Letter G here is 7 minus 1.5. Now, many of you should be able to just know what the answer is, okay? Because these are simple numbers. 7 minus 1.5, and you say it's 5.5. I just can see that. Okay, that's fine. But let's do the process, okay? When you have a whole number, and you're subtracting a number with a fraction, well, I have no fraction part here, so I can't do minus 1/2 from 0. Okay, so if I'm going to rename this, I need to change this 7 to a something with halves that I can do the subtraction of the fraction part. What am I going to change 7 to? What am I going to rename this to? If I want to subtract halves from it, 2 over 2. Okay? Conveniently, my 7s were able to be rewritten as 2s. Okay? 6 and 2 halves is the same as 7. I have renamed it with a fraction part now that lets me subtract this. So now I subtract the whole number parts, 5, and I subtract the fraction parts. Once the fraction part of the bigger number is larger than the fraction part of the smaller number, then I can subtract the fractions. The other option might be easier in this one, to do this as improper fractions. They have to have the same denominator. So what am I going to change 7 to as an improper fraction? 7 is the same as how many halves? Matthew. 7 is the same as how many halves? 14, because this is over 1, right? Every whole number is actually has a 1 as the denominator. And so in order to get to 2, I multiply by 2 there, I multiply by 2 there. Okay, so 14 halves minus 3 halves, that's the same problem as this. The same exact problem, just now it's in improper fractions. So 14 minus 3 is 11. So improper fractions, the subtraction part might be easier without the renaming, but now at the end, you end up with an improper fraction that you have to change to a mixed number. Okay, so the answer here is 5.5. Okay, this flow chart is why adding and subtracting positive and negative mixed numbers is so difficult. Because you actually go through all of these decisions for every one of these problems. Now you do them in your head, right? You eliminate the parts that are, hard when it's an easy problem. But every single problem with positive and negative mixed numbers, adding and subtracting, you go through this flow chart. Are there negative numbers? Do you have to use positive and negative number rules? If not, then you can avoid that stuff and you can either add or subtract, and then you have to go through those pieces. Okay, are there common denominators? Do you have to rename? All of those decisions. This flow chart sends you through all of those on how to end up with the answer to these problems. Okay. Yes, this is why they're so hard, because this is all of the pieces that you have to do for each one of these problems. So let's go back to, let's go to the, like I said, the next assignment, and go to the Pizzazz PA, well, do the link on your, in Google Classroom. Go to Pizzazz PA 32. And your first page. First page looks like this, has 3 problems in there. Okay, so we're going to do these problems together. Now, there's lots of work for these, some of them more than others. Common denominators, we have the equivalent fractions, renaming, all those steps should be shown in your work. What are the equivalent fractions, and any renaming you do, and then your answer, and then simplifying stuff, okay? Some problems don't have that much work if the denominators are already the same, if you don't have to rename, okay? But other ones take lots of steps. All right, so we're going to go through this flow chart for problem number 1. 2 2/3 plus -1.5. Okay, so 2 2/3 plus -1.5. It's really subtraction, right? The answer should be about 1. 3 minus 1.5, about 1.5. Okay, so we go to the flow chart. Are there negative numbers? Yes. Okay, then I go over here to the positive and negative number section. Is it an addition problem? Yes. Okay, now I go to addition rules. Are both numbers the same sign? No, one's positive and one is negative. So our addition rules say that when one is positive and one is negative, we subtract the two values. Okay, so this problem, an addition of a positive and a negative number, is really a subtraction problem in mixed numbers. So now we go over here to subtracting mixed numbers. Is there a common denominator in the two fractions? No. Okay, then I got to get equivalent fractions with a common denominator. Now you probably did all of that just in 5 seconds, not really going through all of this, right? What is the common denominator for this problem? What is the common denominator for this problem? Riley? 6. Okay, 3 and 2. The smallest number that 3 and 2 both go into is 6. Okay, so that means I have to make these two fractions in sixths, equivalent fractions in sixths. So 2/3 is the same as how many sixths? Right, because I'm now here if make equivalent fractions with common denominators. 4/6, because to get 6, I have to multiply 3 by 2. So that means I multiply the top by 2. And over here to get 6, I have to multiply 2 by 3. And so I multiply the top by 3. So it's 2 4/6 plus -1 3/6. Because this is an addition of different signs, I subtract larger value minus the smaller value. Okay, so I'm subtracting now. Do I need to rename or convert to improper fractions in this problem? Do I need to rename in this problem? No, Roman says. Why not? What do you look at to decide whether or not you have to do renaming or whether or not this is the most difficult type of subtraction problem? What do you look at? The fraction parts. If the bigger number fraction is smaller than the smaller number fraction, then I can't subtract the fractions. Is this bigger number fraction bigger than the smaller number fraction? Yes, 4/6 is bigger than 3/6. So that means I can just subtract them. It's not the hardest type of problem. 2 minus 1 is 1. 4/6 minus 3/6 is 1/6. Done. Okay, this is the easiest type of subtraction. Well, other than having common denominators from the beginning. Okay, so on the flow chart it says larger numbers fraction larger than smaller numbers fraction. That's what you look at to see whether you have to rename or convert to improper fractions or whether you can just do the subtraction. If it's if it's yes, then you subtract the whole number parts and subtract the fraction parts. If the answer is no, like the next problem we're going to do, number 4, if the answer is no, then you have to rename or go to improper fractions. Okay, so now let's look at problem number 4. 9 1/9 minus 5/6. Okay, no negative numbers on this one. This is just a straight subtraction. You did this problem in 5th grade. Do I have a common denominator? No, so I have to get one. What is the common denominator of 9 and 6? Okay.
36.
36 will work. 36 will work, but it is not the smallest. That's the easiest common denominator. Okay. What is the least? 18 is the least common denominator. Look at the bigger number here. Does the smaller number go into 9? No, it does not. So then go to the next multiple of 9, which is 18. Does 6 go into 9? Does 6 go into 18? Yes. That means 18 is your lowest common denominator. What do I have to do to 9 to get 18? Multiply by 2. What do I have to do to 6 to get 18? Multiply by 3. So that's what I'm going to do on the top. Equivalent fractions. 9 and 2/18 minus 15/18. Okay, so now I have two fractions with the same size pieces, so I can add or subtract them. In my flow chart, I have already done this common denominator, and now I look, is the larger numbers fraction, 9 and 2/18 is the larger number, bigger than the smaller number fraction? No, it is not. Now I have to do renaming or changing to improper fraction. Why would I want to avoid going to an improper fraction in this problem? So the big numbers, right? I don't want to do improper fractions when the numbers are this big. Instead, I will rename this first number to get a bigger fraction part. What am I going to rename it to? So this is going to become 8 and what? 9 and 2/18 is the same as 8 and how many 18ths? So I add 18/18 to 2/18 and I get 20/18. These two numbers are the same number, but now my fraction is big enough that I can do this subtraction. 20/18 minus 15/18. Well, first 8 minus 0. Okay, subtract the whole number parts right here. Subtract the whole number parts is 8. Subtract the fraction parts, 20 minus 15 is 5/18. Okay, this is the most difficult problem that we have, this type. Okay, if I added negative numbers in there, it would make it more difficult, I suppose. Okay, you could do this with improper fractions. Convert 9 and 2/18 to an improper fraction of 164/18, 9 times 18 plus 2, and then subtract. You get the same answer, except you got to convert 149/18 to a mixed number. Yes, you can't use a calculator even for a lot of these. Number 6, the last one we're going to go over together. Negative 7/8 minus 4 4/5. All right, so we have negative numbers, and then we go and say, is it an addition or a subtraction? Is it addition? No, it's a subtraction, so change subtractions to addition. Keep, change, change. Okay, so that's what we're going to do in this problem. We're going to change it to plus negative 4 4/5. Now we're going to add. Okay, do the numbers have the same sign? They're both negative, so we're going to add them. So it's an addition problem. That's easy. I don't have to worry about regrouping or renaming or improper fractions. I just add the whole number parts and add the fraction parts. But there are not common denominators in this problem. So that means I have to change the fractions to common denominators. That common denominator is 40. Because 5 doesn't go into 8, 5 doesn't go into 16, 5 doesn't go into 24, 5 doesn't go into 32. It's just 5 and 8 times 8. Okay? So if I convert to 40ths, then this has to be multiplied by 5, which means this gets multiplied by 5. And the 5 gets multiplied by 8 to make 40. And so the 4 gets multiplied by 8. And my equivalent fractions are negative 35 40ths and minus 4 and 32 40ths. Equivalent fractions with the same denominator. Since this is an addition problem, I'm adding these two values. I know my answer is going to be negative because they're both negative numbers. 30, so 0, the whole number parts, 0 plus 4 is 4. And 35 plus 32 is 67. So my answer is negative 4 and 67 40ths. This is not an acceptable answer. Why not? Why is this not an acceptable answer? What? It is simplified. It's not an unsimplified fraction because there is no number that goes into 67 and 40. Okay, so it's not that it's not simplified. What's wrong? What's wrong with this? Marcus? It's a mixed number, but the fraction is improper. You cannot have a mixed number with an improper fraction. Okay, you could change the whole thing to an improper fraction and just have a fraction. That would be a really big number. I don't want to do that. Or what is 67 40ths? What is it the same as? 67 40ths is the same as 1 and 27 40ths. That's the same as 67 40ths. So now I can just add that to this. Okay, so it's 4, instead of 4 plus 67 40ths, it's 4 plus 1 and 27 40ths. So my final answer is 5 and 27 40ths, and it's negative because both of these numbers were negative. Okay.